Today we're going to talk about equation of a tangent and normal to a curve. Few things to note. Note that tangents and normal lines are straight lines, hence are governed by linear equations of the form y is equals to mx plus c. Also, to construct a linear equation, you need A. 2 points on the line, B. Gradient and a point on the line. Note also that the tangent line and the normal line, their gradients are related as the product of the gradient of the normal and the gradient of the tangent is equals to -1, where m subscript n is the gradient of the normal and m subscript t is the gradient of the tangent. Let us develop our understanding on this topic using example problems. Let the first problem be, let fx is equals to x squared plus 1 be the function of a curve, and let the tangent line pass through a point A of coordinates 1 and 2 as shown. This is the graph illustrating what I've just read. What is the equation of the tangent through point A? Now the solution process to that problem. Differentiate the function. Step 1. Differentiate the function of the curve to obtain the gradient function or the derivative. And when we differentiate the function x squared plus 1, the gradient function is 2x. Why did we differentiate the function of the curve? We differentiate the function of the curve to obtain the gradient function so that we can substitute the x coordinate of point A in the problem to obtain the slope of the tangent line, because we need the gradient and a point to construct the equation of the tangent. Step 2. Evaluate the gradient or the m subscript t of the tangent line at point A by substituting x is equals to 1 into the gradient function. And when we do the substitution, x is equals to 1, 2 times 1 is equals to 2. And 2 is the slope of the tangent line passing through point A, which has a coordinate of 1 and 2 on the curve. Step 3. Given that the gradient of the tangent is equals to 2 and point A is given, the equation of the tangent is y minus 2 brackets is equals to 2x minus 1. And then the rest is algebra, and we end up with y is equals to 2x as the equation of the tangent. Okay? Let's see problem 2. Given fx is equals to x cubed plus 3x squared plus x plus 1 as a function of a curve, what is the equation of the tangent passing through A with a coordinate of 1 and 6? Solution process. Same thing, we differentiate the function fx is equals to x cubed plus 3x squared plus x is equals to 1 to obtain our gradient function. The same reason as explained in problem 1. And our gradient function is 3x squared plus 6x plus 1. Step 2. Evaluate the gradient at that point A on the curve. And that is by substituting the x value or x coordinate of point A in the problem into the gradient function, for x in the gradient function. And when we do so, it's 3 times 1 squared plus 6 times 1 plus 1 at x is equals to 1. The gradient of the tangent at point A is 10. Finally, the equation of the tangent line. Given that now we know the tangent, gradient of the tangent to be 10 and the point A to be 1 and 6, its coordinates, y minus 6 is equals to 10 times x minus 1. Multiplying out on the right hand side, 10x minus 10, then making y the subject, bringing 6 across, 10x minus 10 plus 6 gives us y is equals to 10x minus 4. And this is the equation of the tangent passing through point A on the curve x cubed plus 3x squared plus x plus 1. Let's move on to problem 3. A parabola is governed by fx is equals to x squared minus 2x minus 3, and a tangent through a point A has a gradient m subscript t is equals to 4. Derive the equation of the tangent. This problem 3 is a little bit different to problem 1 and 2. Problem 1 and 2 were given a point on the curve. We find the slope and use the point to construct our equation of the tangent. But this one here, we don't have a point, but we are given a slope. And so we're given the slope, and since we need a slope and a point to construct the equation of the gradient, we now need to find the point to use it with this slope in order to find or derive the equation of the tangent. So let's see the solution process. First of all, we differentiate the function x squared minus 2x minus 3. Why do we differentiate the function? Basically because we need to find the x coordinate of the point A that when substituted into the gradient function will give us a slope of 4. So we differentiate the function. Our gradient function is 2x minus 2. And since our slope is 4, we can equate the gradient function 2x minus 2 is equals to 4. Hence, making x the subject, we end up having x is equals to 3. And x is the x coordinate of point A that when substituted into the gradient function here gives us a slope of 4. And that slope is the slope of the tangent line. Next thing, we need the y coordinate. So we take the x coordinate and substitute into the function of the curve. The x coordinate is substituted into the function of the curve, not the gradient function. Understand that. Make that distinction. When we substitute the x coordinate into the gradient function, we obtain the slope. When we substitute the x coordinate into the function of the curve, we obtain the y coordinate of the point, as in our problem, point A. So when we do so, we end up having 0, and the y coordinate is 0. And so our point A has a coordinate of 3 and 0. Now we have a point and we have a slope given in the problem. So finally, the equation of the tangent then is gradient of the tangent is equals to 4, and the tangent passes through the point 3a, and so y minus 0 is equals to 4 times x minus 3, and we end up having y is equals to 4x minus 12 as the equation of the tangent passing through the point A with coordinates of 3 and 0.